Hey everyone, it's good to be back. This time I have decided to make a wavefront algorithm. Unlike flat fill, this one contains the information of distance from start to finish, and it's rather complex. These are the steps needed in order to make one, so I will try and include these in the description of the video. So let's get into it. I have prepared a little thing in forward, so the map I'm gonna be using is this one. Yeah, so we'll be starting from the bottom left corner, going all the way up to the top left, and we might as well try another map, so we'll see about that. So about the maximum amount of steps, I shall use a number of elements on the map. However, I will divide this by 2. That will be enough. And next I will make an image that will be based on the map. However, I will make it an unsigned integer 32-bit to have sufficient amount of data to work with. Now, as for the initial filling number, we will have to use a number that is beyond the data already included on the image, so it will not cross the data of the map. So I shall increase that number by 1. We'll be working with higher numbers. Further, my filling number will be just this starting one. It's where I shall start the algorithm with, and then the image on the position, starting position y and x will be just this filling number. Good. So I shall also use coordinates in buffer arrays, so I shall name them x less, for example, and I will need zeros for no data, as much as number of elements on the map, just like this. And I shall do so for the y position as well. And to create a coordinate in buffer arrays, I shall create next arrays as well. So this way I will be able to store data for each step of the algorithm. Very well. Now the initial position, I shall fill the actual coordinate array on its first position with the starting position, and I shall do so for y as well. So now we have arrays for buffering and coordinates. As for the algorithm itself, I shall call it region cycle. We will be going as far as the yes, we have called it steps max as maximum amount of steps. So we shall increase the filling number by 1, just as such. Okay, and also reset the position of the arrays just as such. That's for the last array, and we shall array also do it for the next one as well. Right. So while arrays containing data of coordinates are not empty, which should be looking like this, and the one we have called x last, we'll be looking for its maximum, and if it's more than 0, so it contains data, we shall move the array position by 1 for this array. Then we shall set the current position of x and y coordinates we will be working with. So my x current will be x last, which would be directly on last array position, just like this, and I shall do so for the y coordinate as well. And next step will be erasing the coordinate data from this array. So bringing this number to 0 will make it an empty data. Good. Now we are ready to check the neighborhood. So as we'll be doing it this. Different cycle will be going all the way to the length of let's say xdiff. We have already defined the 8th neighborhood for this task. Very well. So in the 8th neighborhood we shall have new positions. So my x new will be my x I'm currently working with added to the difference. So xdiff on the very position of the difference cycle. This will be checking the 8th neighborhood of the coordinates both x and y. Very well. Now we will be asking some questions, so I shall make an if statement and if my x new is bigger than 0, which means we will need to stay on the map, and also another one will be my x new will have to be smaller or equal to the size of the map, on the second position. Further, I shall need the same for Y position. However, this will be the first data from the size of the map. And also what I will need will be the image must show on the Y new and X new positions a space that is usable. By usable I mean empty. So this, okay. After all this is done, my image, just like this, and the new positions of Y and X will be set to the number we are filling with. Further, my next array position shall increase just like so, and I will also need to store the data, so my X next and the position will be my newfound positions coordinates, both for X and for Y. X and Y, and this really should be it, except for that I also need to prepare the coordinate data that store the coordinates. So after all this is done, while still in the steps, I shall make my X last next, okay, and I shall do so for the Y coordinate as well, and reset the buffering arrays, so the next shall be 0 as well as Y. X and Y coordinates in the buffering arrays. Okay. However, I shall need to do so by setting it to zeros in an array. Very well. Now this should go, and as for visualization, I shall make the image show as such. On the starting position, Y start, and so X. This position will be set as the maximum value. It should show as a white color. Maximum of the image itself. Very well. Further, as for the target position, I shall set this to be 0, which will make the black color. And now, as for showing the image, I will need to show the image, but just like so. I will need to work with the data since we have used unsigned integer 32-bit, so I will need to put the number in here to the numerator, and in the denominator will be the maximum value of the image itself, just like so. So the pixels will be shown properly. Okay, now let's test this up. And there we go. As you can see, our starting position on the bottom left shows as white and is going from the darker colors all the way up to the lighter ends with the black. So now that we can see that Wavefront algorithm is working, we can try it on the other map I have promised. So we will see how it works on it in just a minute. And so after a while we have an image of another map created by the Wavefront algorithm. This is how it looks like, starting on the top left corner, going all the way down to the bottom near right. So this would conclude Wavefront algorithm. Next time I will be finding the path on the map filled with this Wavefront algorithm. So I hope to see you guys next time as well.